Hi, in this video, you learn about PCA, Principal Components Analysis. So the purpose of PCA is to imitate the features of original basis in a reduced form. In high-dimensional statistics, the original vectors are not tractable for analysis. As a solution, PCA can reduce the dimensions of the original vectors. To fully understand the algorithm, you need some mathematical knowledge about eigenvalue, eigenvector, and covariance metrics. For now, we'll just learn how to do PCA with Sklearn, and I'm gonna explain above materials in later videos. So as an example, we'll generate a vector, 10 random vectors filled with random elements, each vector with 4 dimensions, and below figure shows the Python example. And we'll apply PCA to the sample vector we just saw earlier, and the figure shows the example, and you can see that the 10 vectors of dimension 10 is reduced to 2 dimensions by bit transform, and if you want to change the number of reduced dimensions, then you can change the argument n components to other number. If you want to change it to 3, then you can pass 3 to the n components argument. So let's look at where we can apply PCA. And in my earlier video, EEG-based emotion recognition with LSTM, I have PCA the predicted vectors from the trained model on trained data as in right figure. And the code, the link to the video, I'll put that in the description box of this video. And here you may wonder why input data to the model is trained data for the prediction. And if you see the figure on the right, that is the visualization on trained data. And it is because you cannot assure that your trained model is discriminative just by looking at the accuracy, as it may increase due to other regions by fault. For example, in pre-processing, mapping the trained data to all same labels accidentally will give high accuracy no matter no matter your model is learned. And therefore, in machine learning, it is a good practice to visualize the predictions of your trained model with the trained data to investigate the related issues and to assure yourself that your trained model is trained well. And for the code, if you look at the code, the link to the code is also put in my earlier video. And if you see the code, press the predicted vectors are from the input trained data, and it shows the visualization of the predicted vectors from with the trained data. So we'll do tutorial with Python, and you'll do it with me here. So let's open Anaconda, and let's type Python. And as we saw in earlier slide, we'll generate random vectors of shape, maybe 10 vectors, and import numpy as np, and x is np.random.rand. Let's generate 10 by this time 6 maybe, and there was mistake in the grammar, and np.random.rand 10, 6, and again x. Then it shows vectors, and if you want to check the shape, x the shape, there is 10 by 6. And let's do PCA. PCA import from Sklearn, the decomposition import PCA, and then you'll create PCA and its end components. Here we'll try 3, and PCA X will transform the original vector X through PCA, the bit transform method, pass the X bit there was spelling mistake, and transform, and let's check X, the shape of original vector is 10 by 6, and PCA X, the shape is 10 by 3. And let's look at the elements. Here you can see the elements of the reduced form of the original vector X, which is PCA the X. So up to here we have looked at how why we do PCA and how to do with Sklearn. So thanks for listening. I'll finish my video here. Goodbye.